In this episode, we're going to look at a Texas Instruments TPA3116D2 amplifier module, put it through its paces, we'll listen to it, we'll look at the ugly waveform on the scope, and basically study this thing. So let's take a look at what I have. So in this video, we're going to look at this little amplifier module. This is a TPA3116D2. It's a dual channel 80-watt digital power amplifier module that I got from the folks at IC Station. And here we take a look at the specifications. We will see that it's built around the TPA3116D2 chip. And here's our specifications. It has over voltage and under voltage protection, overheating, DC detection, and short circuit. It'll operate between 12 and 24 volts, and it has a maximum output power of 80 watts times 2. Well, not according to the specs published by Texas Instruments, you know, the people that made this chip. According to Texas Instruments, this chip supports 2 times at 50 watts into a 4 ohm load at 21 volts input power, 2 times 30 watts at 8 ohm loads with a supply voltage of 24 volts, or 15 watts if you're only giving it 15 volts supply. It will accept the voltage rating between 4.5 and 26 volts. It is a Class D amplifier, greater than 90% power efficiency, has a low idle loss, a very small heat sink, advanced modulation schemes, multiple switching frequencies to avoid AM interference, master and slave synchronization, frequencies up to 1.2 megahertz switching frequency. So this is way beyond anything your speakers could ever deliver, right? And it's actually a very good little chip here. Very small, very efficient, and we read the description here. The TDA or TPA3116D2 series, because they have multiple chips in this same class. It's a stereo efficient digital amplifier power stage, and they have modules that will deliver up to 100 watts, but this one here is rated at 50. So the description goes on to continue that at high efficiency, it allows it to do 2 times 15 watts without any heat sink whatsoever on a single layer PCB. It can run 30 watts per channel into 8 ohms without a heat sink on a dual layer PCB. That's because the second layer will actually draw the heat through it a little bit better. And up to 50 watts per channel times 2 into a 4 ohm load with a small heat sink attached to the top side of the chip. It says all 3 devices share the same footprint, so a single PCB can be used across different power levels. So there's different chips that they have with different power levels. And the highest power one is a 100 watt 2 ohm mono design. This one that we're going to look at is the 50 watt 2-channel stereo. So the TPA31XX, so XX, so for the different chip parts, has an advanced oscillator PLL circuit employing multiple switching frequency operation to avoid AM interference. And this is achieved together with an option as either a master or slave, making it possible to synchronize multiple devices, so that way you can have more power. They're fully protected against faults, short circuits, so forth, thermal protection. And faults are reported back to the processor to prevent the device from being damaged during overload conditions. Here we'll look at the block diagram of this. As you can see, it's a Texas Instruments chip. And if we look at this, it's a conventional pulse width modulation logic. So it's turning out a PWM bit stream. One thing I've noticed is on the amplifier board, when we actually look at it, there are no big bulky chokes, output filters as in conventional Class D. This one here is using little SMD ferrite cores and SMD capacitors, so it's very small, as we'll see. Let's take a look at the actual board itself. When I test run these amplifiers, I generally use a battery, and in this case, I'm going to use 2 12-volt batteries connected in series to give me 24 volts, so that I have the full power available. And I know I'm not going to be using extra heavy wires or anything. I'm just going to use a couple strands of Cat 5 or Cat 6 twisted together because for the power levels that I'm going to be putting through this thing during this test, this is going to be more than sufficient. But here's a picture of the amplifier and so forth, and that's what comes in it. And you can see they got the price on there. Of course, the price is subject to change. That's what it is as of today when I'm doing this review. So without further ado, here is the amplifier. It arrived in the mail. Let's crack it open. I haven't even opened this unit yet. So when you get one of these units, it comes sealed in an anti-static bag. And there's what it contains. It contains an audio cable that you can plug it into your sound card on your computer, because this type of amplifier could be actually mounted inside a computer. And it comes with a bass, treble, and a volume control. Here's our inputs and here's our outputs. I'm going to connect this up to a RCA type cord. Actually, I might even have to look and see. I might even have one of these made up. And then we'll plug it into some equipment, hook it up to some speakers, and we'll test it out and see how it sounds. Okay, here's the module with the knobs on it. I did find my cable that I made up before. I made this one up a while back. I've got both the sync, well, they're both two plugs, but as you can see, the connectors on the end are different. So I've got a double cable made up here, so I can plug it into the various amplifier modules. We're going to plug in the audio cable here, and I'm going to hook up my speaker leads. I've got my 2 speaker leads here for my PSB test speakers. We'll hook those up to the speaker terminals, so there's a positive and negative for each terminal because it's a bridged tied load or BTL output. So we're going to need 2 wires for each one. They cannot be a common ground, as in some amplifiers. If you put the 2 negatives together, you'll result in a shorted module. But let me hook up the speakers. We'll hook it up to a pair of 12-volt batteries in series to give us the required 24 volts, and then we'll connect this up and do some sound tests. So I've now connected my power conductors. I'm going to use the blue wire as my positive and the green wire as my negative. So let's just pretend that the blue wire is red, because I know that someone's going to say, make a comment. It doesn't matter what the color is as long as we get it the same way on both ends. This is just for testing. My left channel output here I'm going to connect up. Now my color codes on these is the white wire is the negative, the colored wires is the positive. This is just using my Cat 5, or I think this is actually Cat 3 for my test speakers. So we'll tie them down. Okay, we're going to connect our power wires up to the battery. Okay, I've got my power connected here, as you can see. All I need to do is just put my jumper between the positive on one battery and the negative on the other, and that will turn on the power. And of course, make sure that we're not cranked up here. Oh, my cat came in to visit me. Just waiting for the heat to shut off in here. I got my Bluetooth device now. Got my Bluetooth device hooked up. As you can see, it's paired. Okay, now let's listen to some music and see how good this little digital amplifier sounds. Bass and treble. It's amazing, you can't even pick up the tape hiss. This is obviously analog recorder. Listen. That's actually not bad. I was quite impressed. You know, to pair a Bluetooth receiver to this little amplifier, that is cool. That actually sounds very good. So let's try this one here. This is the good old 2001 theme done by Jack Waldemar of Music Bakery. I'll test it with the line out from my phone directly plugged in, so we'll eliminate the Bluetooth link. It shouldn't make any difference actually in the sound, but let's just take a listen. I'll drive both channels too. Just gonna hook up my test clips here. To my tone generator. It is loud. I don't want to blow my speakers up either. Let's look at the output on scope. What's weird on this unit is, it's going to wait for that fan to shut off. When I'm feeding a tone, this is actually a digital output that's going to the speakers. This is not like a conventional Class D. Take a look at this. Let's wait for that racket to show up in the background, but how does that look like an audio signal? It doesn't. You've got all these, what looks like spikes of noise, and then your audio signal gets modulated. And here's another interesting thing. Listen to this. When I disconnect the scope, the frequency changes. To look at this on my analog scope, and I thought, what the heck am I looking at with this waveform? And I put the digital scope on it to get an idea. I'll show you what the analog scope looks like. It looks weird too. See what I mean? The analog scope, you're seeing the noise, and it's hard for the camera to pick it up. This strobing, you see, this is the shutter and the rolling shutter in the camera. But there's the audio signal. It mixed in with the noise there. I mean, this thing defies everything that you would think of as an amplifier. You've got this high frequency noise, which is showing up here on the digital scope as random, looks like random spikes. But you know, when you play music through this thing, it actually sounds very good. I mean, it defies logic. You're looking at this waveform on the scope thing. What the hell am I looking at? But I mean, look at the digital scope. It looks. I don't want to shout over the music here, but I mean, it looks like we're looking at basically a square wave. I mean, what a joke. When you look at this thing on the scope, it doesn't look pretty at all. It looks ugly. On the analog scope. Let me just see if I can put my bandwidth limit on here. I mean, that thing in no way represents what I would expect to see from a signal. Even the Class D amplifiers that look clean, this looks like just a mishmash of noise, but the sound quality of this thing is just amazing. I can't believe how good it sounds. You know, looking at the scope, as I've said before, this deceives you, because you see this and you think, how can this possibly sound good? I'm not going to bullshit you here. This thing actually sounds good. I don't know how well it's being picked up by the camera, but I've played this thing a few times here, and this thing sounds amazingly good. I mean, it defies the senses, because you look at the output from the scope on this thing, and this thing looks like, what the hell? What's all this noise in here? But this is a digital amplifier. Anyway, that's a quick. I didn't think this video was going to go on this long. I figured I'd be in and out of here and play one track on this thing and be done with it. But this thing's amazing for what it is. No heat whatsoever. I mean, I've had this thing running at lots of power. Like, I've had it running almost all the way up. And yeah, I'm not giving it enough current to do a full current test. It's going to need a few amps of power to put this thing up to full power. I wasn't taking it anywhere near its maximum output. Link to where I got this is up on the page here. Say, this is an inexpensive unit, and you know what? I think for what it costs, it certainly delivers very good results. And I would have never thought that when I first saw it, but you know what? Hearing is believing. This thing actually sounds good. Here's the typical Class D amplifier that I've seen in the past. You've got these big inductors, and you've got your capacitors, right, that form your low-pass filter to cut off the high frequency, because this is a pulse width modulation amplifier. They call it a Class D, but it's really a pulse width modulation amplifier. If you look on this one, well, there isn't any. You've got a couple capacitors over here. This is on the input side, but there's nothing between the output IC here and the speaker terminals. It just goes right to the IC. So this is a different design, and we'll look up the specs to that IC and show you what this one is. I didn't know what to expect on it, but man, I'm quite impressed with the results of this thing. Anyway, this came from IC Station. Their link is on the bottom of the page here below the video, in the description, where you can get one of these things. They're not that expensive, and I would recommend, if you're looking for a little amplifier for a project, that this might just be the answer for you. Again, thanks to all my PayPal and Patreon supporters out there. Without your continued support, I wouldn't be able to continue these videos. You can support me right there. That's how you support my channel. As always, thanks for watching.